days, gone are the days, as a developer, I could run to my IT ops and say, guys, open these ports for my application. Now is the time where applications are looking to define what ports they want, and network needs to understand what the application's requirements are and get it deployed using Heroku, OpenStack, or Mesosphere, right, whatever. In that context, we'll see what the networking platforms like VSP from Nuage provide, which can help application developers, and where the common ground is going to come for the intersection. With that, I'll hand it over to Florin. It's a real pleasure to host you.
So thanks to Symantec and the sponsor for organizing this. I'm Florin Balus. I'm in charge of product management at Nuage Networks. And because we started that way, we are hiring too. But wait until the end to see basically what we are doing, and if it matches your career interest, just go to our webpage and apply in there. So I'm here today to talk about a very interesting subject, in my opinion. So it's about the application services framework, and I was thinking how to describe what this is before we start on the technical details. And the best way I could describe it is the way Mark, the CF Engine founder, was talking about networking tools. So I saw a blog from him about 10 days ago where he was making a comparison between the medical and the high-tech world, where he was alluding to the fact that we are all techies and we love to build surgery tools. Everybody builds surgery tools. We did it, everybody did it in the SDN space. But what our IT customers usually need, they don't need surgery most of the time. They actually need a pill. You have a headache, you get a pill, you solve the problem. So what we're trying to do with this is simply like provide the assembly line for pills, the research facility and the assembly lines for IT admins to actually produce repeatable pills for their users, okay? So with that, I want to describe a bit the structure. So basically, today I want to start by sharing a bit, what started our vision here and what we believe in. Then I'm going to describe, because I don't know how many of you know what Nuage is about, I'm going to describe our solution a little bit, give you a sense of where we are successful, and then I will use two customer use cases, the most interesting ones, to lead into this application services framework discussion. At the end, I'm going to do a demo, and until probably 20 minutes before I came here, I was going to run the demo, and then somebody told me there might not be any facility, so I kind of recorded it, and we'll go through the recording part of the demo. I will entertain questions. In general, I was an ITF guy. I'm used to questions. You can stop me. I will try to be polite and stop you when I feel like it doesn't match the rest of the people's interest, right? But definitely, you can stop me and we can discuss. So I want to start by explaining who we are. So we started about 2.5 years ago, more than 2 years ago. We think of ourselves as a leader in SDN networking space. And we are located here in Mountain View, very close to here actually, less than half a mile. We basically are an Alcatel-Lucent venture. We have our own building though, and we kind of own the strategy. Pretty much when we started the company, we were looking to mix up cloud technologies with networking expertise. And the team is built that way. So we have a number of people that really are into cloud technologies, and then the other half of the team built probably for 12 years networking policy-based solution for mission-critical networks around the world. So it's that sort of mixture in the team, and I think it's a very interesting environment, very startup-like environment in our building. So what got me started on this, right? It sounds like I was really old, but I am like 22 years old in networking. I started with X25. If anybody remembers what that is, okay, I'm that old. But I went through probably about 5 transitions in protocols and much more transition from a hardware perspective. And every single time when you want to spin a new ASIC or a new network processor, it's like taking basically about 2-3 years for those guys to get it out. Broadcom probably a bit more. And then you have to add some time to build the cards, to build the 4 factors, and then it takes a while to build the software features on top of that. And every vendor I've been in was doing a full integrated stack, right? And this has a bunch of problems. Like, really, in the last 8 years, there wasn't any serious startup in networking beyond just regular switching. And customers, as a result, don't have that many choice, right? And there is basically that service velocity problem with long hardware refresh cycle. So when SDN came on board, the ideas were rehashed a number of times in the past. In reality, I'm seeing right now the right environment to actually provide specialized development, separation between components. So we are definitely focused on building policy and controllers. Now, if you are looking at how much it takes to build a serious networking startup, it takes probably close to $60 million to actually do all the stack. But if you provide this type of specialization, you can hire skill set to build every module separately. Definitely basically starting with policy and controller. And then there are companies building operating system, programmable operating system, like Cumulus, Intel is doing a programmable operating system. Arista is offering a programmable operating system. Even incumbent vendors have some programmability in their operating system. And the cost of building a hardware startup is really, really low. Like, if I depends on where I want to build it, might be possible to do it with less than 5 mil to start basically a hardware-focused startup. And of course, because of that, customers are in control, have more choices. And in every one of these components, they can switch the vendors if they don't like it, as long as the strategy to build these solutions is consistent between different modules. So I think we are actually closer to be able to implement this sort of model. And this is what happened with Spark Station and HPUX. When I started, I got a Spark Station that was $25,000. It had basically dedicated operating system and applications. Now all of us are treating it as a normal thing to get a x86 server with Linux and apps on top. I don't see why not in certain area of networking we cannot develop this sort of model. I actually believe we can actually right now. So now when we started, we really look at what they were calling data center automation. So the way I associate the data center automation of 2 years ago was like this sort of like puppet controlled by a manager of manager. So we have a number of companies that build this sort of manager who are right now sold for spare parts. It's a done deal. Can't be done. It's not working really. Now we had a bunch of SDN companies who try to improve the manipulation of the strings at the top. They build some components in there, but pretty much if you want to tell me, for example, I'm the puppet, you want to make me move there, it takes you probably about 1,000 instructions to do that. In my opinion, real SDN is about actually building a brain into your solution. This is the good robot, not the bad one, okay? So you have to have a brain in your solution, and it has to be based on abstractions that are easy to communicate. If you tell me move there, you don't care about the rest. I am taking care of the rest, okay? I can move. So basically, why it is important for the SDN solution to have actually a brain, okay? If you don't have a brain, and that's the way most of the SDN controllers went originally, right? And even right now, there are a bunch that go this way. They are hardwiring their SDN. Every integration with top layer policies that enterprise and IT organizations run takes a lot of development, and this sometimes is provided by the IT guys. They have to develop the translation to implement those 1,000 steps in these freaking controllers. So if you have a policy brain in there, and the controller is just the heart and the sensorial system, basically the policy brain needs simple instructions. The integration takes very little, and you can make it consistent between different type of policy systems, okay? So how did we build our solution? So we have what we call Nuage Virtualized Services Platform. So this is basically the assemble that describes our solution, but we are basically oriented around 3 components, all of them running on virtual machines, okay? So the brain is the virtualized services directory, okay? So this basically is the brain that keeps the network policy engine and the abstractions. And then basically in there we have other functions like user permissions, user hierarchy. We have in there basically analytics module and many other things. But pretty much think of it as the brain. And we have redundancy in there. It runs on multiple virtual machines. Has MySQL database there, all of that stuff, okay? All of that good stuff. But here you can observe the decisions we made in terms of choosing to have a brain in there is that we integrated right from the beginning with multiple cloud management systems easily, right? So right from the beginning, we supported OpenStack, VMware vCloud vCenter, and CloudStack. And the integrations we are doing with enterprises or cloud providers are taking us much less than in other cases, right? And this is consistent across networking. Now, underneath this, we have our controller, what people call a controller function. So this controller function is also running on multiple virtual machines. And this is equivalent to what people call a controller in other solutions. So at the core, this controller has our Alcatel-Lucent IP division software that is running probably in about, I think it's close to 500,000 devices deployed in carrier networks around the world. So the main task I had when I got the software was to actually cut probably about 15,000 lines of code and CLI out of the software. We had much more than what we needed for a basic controller. So we optimized it and we ported to run on virtual machine environment. This was also a software that was already virtualized for large test environments. So we really benefited from a lot of work that was put in there. In general, this is basically what we are hearing from customers. This is a solid piece of software. Runs very well, and once we get in the lab, we are usually very successful. Now, basically, this controller talks to individual forwarder components. So the top one is the management system, if you want, policy system. The bottom one is the control plane representative. And here we have a number of what we call virtual routing and switching agents, right? And these are running basically in different type of forwarding elements. And this agent has the role of translating all of the different data plane components. Either could be a gateway, a 1 terabit gateway, or could be a simple server that does 10 gig, translates that to the controller, right? Provides a consistent interface to the controller. And when we build this virtualized routing and switching agent, we were debating how deep we cut into existing open source agents. And originally we did some cuts in there. The main problem you have when you do cuts into the open source virtual switch, into the OVS, the main problem you have is very hard to certify. When you actually get into production environment, you suffer dearly from not being certified and not supporting different distributions that the customer are using. The certification list is this big compared with this. So basically we took this out of the kernel space, and the certification process is a breeze. And we are using OVS module in there, and then we have our extensions in the user space like an app. Okay? So now, this controller supports basically thousands of servers. Now, if somebody wants to extend the services, the networking services across different data center modules, could be pods, could be data center locations. In most of the controller case, from competition, they have to add a VLAN gateway. They have to translate the network virtualization to VLANs, do a handoff, go back to the router. That's how they can extend it. There is no consistent policy applied across domains. In our case, adding another data center structure in the same location or across the wide area network, it's a matter of instantiating another controller function. So this scales naturally the way the internet scales. You can reach high volume deployment, and it's consistent, and it doesn't require any modeling with the data path. Okay? So this could be extended laterally, and the good part about the controller is we got it out from a router, so it supports all the wide area network protocols and the underlay protocols. So in essence, basically, we are able to correlate with what's happening in the underlay easily. There are a number of mechanisms we developed in networking world to know when something happens in the underlay and react right away to that sort of stuff, like BGP next door or IGP components, right? Once you know what's in there. So we get full report from the underlay and we react at service level. So I wanted to actually get back into the policy framework, because to me the networking part actually was the easiest one and less interesting to do actually for us. I think integrating and building the field part and addressing application needs was what was the most difficult part. So basically, let me go through the workflow, starting from the overall policy engine that people have. So there are initiatives in OpenStack like Congress who are trying to build that in a consistent way. But the reality is that there are lots of customers who already developed their own policy engine, and it's probably 3 years ahead of those initiatives. So that policy engine is where they define what their application need. And out of that, they generate primitives for the compute part and for the networking part. So that's step one. There is a push down policy component step that tells the compute what to do and tells the networking part what to do. So we are handling both networking and security policies, and basically we are able also to chain in their different application functions as well. But pretty much that's step one. It comes to Nuage VSP and talks to Nuage VSP in an abstract way, exactly how they develop those policy engines. And as soon as the compute actually pushes down the compute somewhere, it could be in any rack, we don't have the knowledge of the location in there. We find about location when the event comes from the network and tells us that particular compute instantiating in that particular server. At that time, our controller with the VSD assistance, with the brain assistance, generates a policy that is instantiating in the network. And now is where we actually get to the network virtualization piece. This particular policy generates a topology, a service topology that could look something like this. It could be a service topology that connects basically virtual machines across different data centers, and it could interconnect them with layer 2 VXLAN or IPVPN VRFs. It could put in their security rules, distributed security rules, or centralized security rules according to a certain design. Okay? Whatever the design comes down on us, we are implementing it. Okay? And this is where all the networking stuff happens in the middle. But that's basically something we kept doing for a long time. That was the easier part. Basically, doing the integration is what I found people were having difficulties with on the customer side. So now, just because this is a network virtualization event, I will step briefly on how this happens in a bit more details across data center domains. And then we get into the customer use case and application services framework. Do you guys have any questions up to now? Because I'm speaking fast, not because I want to shut you down, but that's how I am. Okay.
So I have a bunch of questions. I've been away from networking for a while, so you can call me dumb if I ask a dumb question.
Don't worry about it.
But I'm thinking about policy. Policy is something that has to be compiled on a network-wide basis for it to be coherent, for it to not conflict, especially when you're doing things like firewall and other things. So my question is, who does this verification of the rules that it would be accurate, good, correct on a network-wide basis? And
Okay.
another question which is...
Let me answer that one,
Okay.
and then because I need to repeat it, because I don't think they heard it over there. So he's interested to know, comes down a policy decision for networking from the top layer, who implements that, who provides consistency across all the domains, right? That's the function of the VSD, right? And by the way, this is how, your cellular phones get connected. There is a policy engine that defines that across, this is not my cellular phone, this is over there. But that's how the policy is implemented for cellular phones, for BNG, triple play, for a number of policy systems that you are using every single time. There is a policy engine that provides the consistency part, and VSD is basically following the same principles in that. It's syncing up the policies across. Okay? Just one moment. Let me just take one question. And we're getting just one more, because otherwise we're going too much.
You mentioned that these are alerts coming from the nodes, and then the reaction comes from the top. Is it not the discovery way? How is it different from?
Yeah. So the question was, I was mentioning that there is basically communication coming from the network to the controller and the policy system, and he was expecting a discovery phase. So there is a discovery phase, that's phase one, where you actually are being told what to do by the top system. But it's an abstraction that is communicated. It says basically, hey, you will see when I do the demo, but it will tell me, okay, you have a frontier which is implementing web services. When you see basically a VM in the web tier, implement this sort of policy. That's the level of abstraction that we expect is the right one for communication from the top to the bottom. The top doesn't know stuff about VXLAN or anything like that. And the VSD has to be able to compile that and translate, okay, so what he's talking about is I have to put a VXLAN subnet in place, and then I need to put a, business logic tier in the bottom, and then a database tier there, and then the policy needs to be smart to say, that means 3 VXLAN entities connected by a router, and these security rules between them, okay? Has to be smart enough to translate that into networking primitives. That's what we kept hitting at all those integrations at the end of the day. They didn't have that translation done, okay? Now that's the discovery phase. The other part is simply the same thing like the cellular phone. When the cellular phone opens up, attaches to the tower, that's when I get the ID into the policy and tells me this is a web server. And then the policy says, oh, okay, this is a web server. I need to give that policy, put it into a VXLAN, all that sort of stuff. That is just base networking stuff. So I'm taking one more, and I can come back to you, but I want to give everybody a chance to go ahead.
Yeah, so when you create this policy, do you have, how did you create it? Because earlier I saw you have a service template. Is it using that service template to create, or how did you, or is it something that you have a portal to use it? I mean, how did you create this policy?
Also, the policy definition, the policy instantiation is ordered from God, from the above policy engine, right? It's a policy system that basically touches application level and communicates with storage, with compute and networking, right? So it's coming from God, but there are possibilities in VSD to actually let the networking and security team dictate what we call a template sandwich, to say, hey, you listen to them, but to a certain extent, you put these security rules at the top, and don't allow them to bypass them, right? So there is a certain level of control that you can define. And you will see when I do the demo, I will touch base a little bit on that, okay? But that's what I found. So by the way, I'm going to stay after the meetup and talk to you all, but I want to leave it, when we interrupt, it's going to be like 3 questions, and if I see that we're going too far with one question, I will maybe just stay with one, okay? So that you guys maintain the flow to understand what I'm talking about. So, okay, so let's see how the deployment goes between multiple domains, okay? So let's assume that you initially start with one data center domain, you instantiate a VSC function on a bunch of virtual machine in redundant mode, and you have 3 VMs instantiated there, the policy is applied, you have a certain service there. You know, could have that template I showed you about in the previous one. Now, let's assume this is basically, I call it Brooklyn data center, okay? Let's assume people want to instantiate, extend the SDN solution to the next data center. And let's say that's in Manhattan, right? So the only thing they need to do, they could put it under the same controller, but usually people are instantiating other 2 or 3 VMs in there to do the controller function, right? And that controller, automatically when a VM is pushed by compute here and is reported as a web VM, brings that VM back into the service automatically. No need for gateways, for VXLAN to VLAN mapping, all of that crazy stuff. Okay? It just automatically goes east to west and establish connectivity. And it could be a wide area network in the middle. The controllers, we implemented right from the beginning a federation of controllers. They talk to each other, exchange information. They set up all the forwarding entries through RIB exchanges and all of that stuff, okay? Without involving the brain. The brain has to be focused on translation and other higher level things. Now, if somehow I want to expand the services to the wide area network, the controller talks and behaves like a router and could talk to the wide area network router or to a VPN router automatically. We're using protocols that were implemented for years by all the router vendors, right? And we know they are interoperating. So right from April 2013, we could do that without actually any problems. And that's basically what's happening to expand connectivity across domains. So pretty much as a timeline of what we did in the last, I would say, 2 years, we had a number of firsts that we introduced. We weren't that focused on marketing them, but pretty much we were the first policy-based SDN solution. And you know, we did also the first totally distributed solution. We don't require like a network node in OpenStack or a VR in CloudStack. Everything is distributed all over the place next to the virtual machine and basically goes right in between virtual machines right away. We implemented control federation that allow us to scale across domains and wide area network interoperability without gateways. And we did demo recently also, not only with regular IPVPN encapsulations, but VXLAN interop with the data center gateway. Okay? We kind of developed this in sync with the IPD guys, so we are able to do VXLAN in there for both layer 2 and layer 3 stuff. And there are some RFCs that were also completed between us, Cisco, and Juniper in that space. So we follow those RFPs, and you can use any one of these routers whenever they implement the VXLAN. So in between, since we started in April 2013, we also went through like about 4 releases since then. So in the current release that's coming in Q4 of this year, we are launching this application designer that I'm going to demo here. And we are also the first SDN solution to support containers. So we actually have a customer testing the containers in their project. So we, as I said, started with an approach where we are multi-hypervisor. Now we added containers in there and multi-cloud management systems right from the beginning. So that's what I had to say about Nuage. I wanted to touch base right now as a generic description. I wanted to touch base on, I wanted initially to just talk about one customer use case, but this one is such an interesting one, and I'm so proud of this deployment. I wanted to bring it up, although it does not necessarily relate to application services framework. So OVH is a large cloud provider. I don't know if you guys saw the announcements, but they opened in Canada about 12 months ago, probably the largest data center we had in a while, 300,000 servers. They have a very interesting model where they provide a wholesale service. I call that cloud as a service. So they just announced the beta availability for Nuage as a service, part of this cloud as a service. So they basically allow customers to go in there, push a button, instantiate their own OpenStack controller, and Nuage underneath as a policy layer and controller, and dedicated server. So they actually have a number of cloud providers who were very successful by just focusing not on building the cloud, but building a specific business model to attract customers. So this is something we won some time ago, and it's been in the works. Right now it's going to be available very soon. Meaning that we've been trusted to actually provide a scalable isolation between, not only between tenants of a cloud provider, but also between multiple cloud providers. And they are using also, they are offering to the customer our Nuage VSP designer and the monitoring component, which they thought was a great differentiator. So that's on this one. Now I will jump into what motivated us to do the application services framework. So basically, in the private cloud use case, we had a number of customers who were using VMware ESXi from the beginning, right? So they had a long history. They deployed a number of ESXi clusters. And they were considering introducing in their open source hypervisors like KVM. And another requirement they had was to be able to migrate compute from bare metal servers into these kind of hypervisors, right? Definitely they wanted to address the manageability issue across ESXi clusters by putting OpenStack at the top. But then they wanted a networking system that will allow them to provide also easy networking across clusters and support KVM hypervisors. And also allow them to do physical to virtual migration. That was the original stuff they wanted to do. And it was about multiple data center domains. So we had 6, 12 different type of environment. So they wanted to be able to scale, to interconnect them eventually, right, as they were growing up. They didn't want to have to put software in place, software gateway in place. That was a no-go from the beginning. And definitely they needed a lot of scaling and isolation. That was the starting point. But then when we started to talk about the architectural stuff, it was very interesting to see a common pattern across the enterprise customers. Most of them actually had specific application needs. And the design was following the following trend, right? They wanted usually a development environment, a QA, and a production environment. They wanted them separated. So they use our routing domain separation. They wanted inside every one of these domains to build projects. And inside the projects, they wanted development sandboxes. So We had a structure in the policy brain to actually accommodate this sort of stuff. But as we were going through the integration, they were pretty much translating their needs to our basic networking primitives we started with, and everybody support at this point in time. So there was a little bit of explanation we need to do every single time. And then we stepped back and we said, look, what they are talking about actually requiring this sort of workflow. They wanted to be able to, from an IT admin and application designer perspective, they simply didn't care that much about networking primitives. They wanted to be able to say, hey, I want shared services connected to the development domain, and then I want to put in there like a 3-tier app. And I know I put here just 2 tiers because internet doesn't count, but I was running out of space and was becoming ridiculously complex. So they want to build this sort of stuff, and they want this to be mapped to networking right away, automatically. So then we started to think about this component. How can we do this in VSD? And because we have a brain, we just need to add a little bit of more neurons or translation module to the brain, right? So we added this VSD application designer, which in effect is a bunch of basically policy components reflected in, of course, REST API interface and user interface to show customers what they can do with those primitives and REST API calls. Okay, so pretty much that's how our application services framework came to be. And basically, this is how it works at high level. So usually what's happening, I'm showing here 2 screens, and we do have these 2 different personalities inside VSD. There is a network designer personality and a screen, a UI, where you can see what gets instantiated in the network. And then there is the application designer at the top that allows people to actually shape their application design. So I'm showing both of them so you understand how things are getting in place from a networking perspective. So usually in step 1, they go in there and they design a routing domain for development, separate one for QA, and another one for production. They connect them to the internet, they put the security in place, done. That's done once, okay? Then basically, that's when the IT admin goes into application design. And in the application design, he might say in there, I need 3 services for the developers. I need DNS, I need the Puppet service, and then I need in there management, okay? I have to connect to the server somehow, SSH or Telnet, whatever they use. So that's step number 2, and that's done also 1 per domain, okay? Then, as the application designers or the enterprise admin designs applications, they go and do in a repeatable fashion this application design, where they say, I want the internet to connect to the front end using HTTP and HTTPS service, okay? I want the front end to talk to the business logic, could be a JBoss service, using JBoss. And then that one to talk to a MySQL tier, which I'm not showing here. That's what they usually do. And that could be repeated across sandboxes, so there is a need for templating, that sort of stuff. But pretty much, that's what's happening, and I forgot to make you guys track down there what's happening. So as soon as the shared services are instantiated by the designer, or coming down from a policy engine, automatically we create in there a VXLAN, and we create different policy rules here. We might put QoS in place, we might gather stats for every individual server that implements this DNS service, okay? The same thing when projects actually instantiate the application tiers, we put inside each project maybe a new VXLAN, or we extend the existing VXLAN to emulate a subnet, and then we download the policy rules in there automatically, okay? Now, okay, this is actually instantiated in this step 2. This is instantiated in our database, but it's not yet placed in the network because there is no VM or no compute instantiated yet. Okay? So this is basically the brain understanding from the top layer what it needs to do in detail. Now basically, I'm going to show in the demo actually the last step. I'm going to show the example of a development domain, 3-tier application. The first one will do HTTP, HTTPS, so it's going to be a web service. JBoss, business logic, and then here a database running MySQL for this application tier. And we will have a step 4 where we actually go through the next step where the developer says, I want 10 VMs running web services, 4 VMs running JBoss, and basically database, another set of VMs. Okay? And you will see basically that instantiated, and then we'll go to OpenStack to actually show you guys that being instantiated. And I'm going to take questions here before I go to the demo work. You guys want to see the demo to fully understand this?
Yeah.
Demo?
Demo.
Okay. Okay. So kind of difficult to see that. Okay. Let me see here. I need to have some perspective too. I want to make sure I explain it as I go through the demo. So, and bear with me because we just did it before I came. So basically, we will basically define here, basically, as I said, we'll have some shared services like DNS management running SSH, and I think we put in there a Puppet service, okay? So basically, the interface has the capability to define what we call application services. So this could be general for all the enterprise. So it's basically the place where you will do once a populating of all the services, and what that means, it means you put in there what kind of ports the services are using. Those are tables that people are using manually. Every enterprise admin has a table like that and know what ports they are using to communicate, okay? But we have that populating in VSD. And basically, here, I'm showing how a new service could be added. Let's say the admin forgot the DNS service. So basically, we create a DNS service, and we put in there the destination port. It's right underneath. That gets created at the top, like a DNS service. So basically, right now, we are designing in step 1 the basic networking domain, right? So pretty much, in here, we create a domain, and the way we create the domain, we use a template, you know, because you might want to create at least the QA and development domain with the same kind of rights. You can use a template for that, right? So you create a domain, and then you will see here, this is pretty much a pretty simple basic domain that I'm creating here. Okay? Just hold on, let me go through the flow so I don't lose people. We can roll back to the demo. Okay? So basically right now we are in application mode. So we are in step 2 where we create the Puppet applications for an individual domain, for development domain. So we go in there and we add those shared services in. Okay, so we add the Puppet. Okay, and how do we add the Puppet? We have an application tier, and in this case it's just Puppet service that we create in there. And that Puppet service automatically gets an IP address pool and all of that stuff in the background. They don't have to worry about it. Then we drag the domain. This is a placeholder for the application domain. And we say in there, okay, this domain communicates with the Puppet, and we allow the domain, everybody in the domain, to communicate to the Puppet servers using the Puppet service. Okay? And we do the same, I think, for DNS. We put in here DNS, kind of the same kind of stuff going on for DNS. And you will see, I think after that we put the management. I hope they put the management. DNS service. Okay. And this is the domain, the placeholder for domain, adding DNS service to the communication. Okay. Did you realize I'm talking way faster than this? So the last one that we create, I think, is management, and we put in here SSH. And it's the same thing, right? Communicate from the regular domain to management. We put SSH and telnet in there, okay? So this is basically once per domain you attach these shared services, right? And everybody can use them. All the servers in the domain can be managed by Puppet, right? Now we create the website, that application that is providing web services to the internet, okay? So inside there, this will be a 3-tier application. So we add the first tier, and we call that front end. And that front end, you will see, will communicate down to a business logic, internal business logic, which basically talks JBoss to the web server. Okay? And then finally a database service. Okay? This will be a MySQL service which is used just by the JBoss. We could have done it as a shared database service if that was the design. Okay? And as soon as you add this in there, of course you need to allow the internet to access the front end, the website, right? So we put a network macro we call internet, which identifies basically the outside world, the wide area network. And in there basically we will enable to talk to the web servers on HTTP and HTTPS. And on top of that, this is getting ahead of me. On top of that, of course, you have to allocate public IP addresses for the server. So you saw in there creating a floating IP for that component, right? So now, the whole thing got instantiated here. And we don't jump directly in OpenStack. We will go through one more thing here to see basically what actually got created here. So basically, we are going back to the application tier. And this is the brain understands everything that needs to do. Now actually the policy component needs to order the VMs in different application tiers. So this is what we are going to do. We have on our interface the possibility to actually call, compute, and establish the virtual machine instantiation in there. But this will be done by a policy engine at the top. It could be done by our staff because we wanted to be able to support, telco services where they want to own the service chain as well. So basically you will see us here activating in a particular front-end application. So we then go in there and here it is a virtual machine that gets instantiated and assigned to the front-end tier. You saw that we selected the front-end part. So this is a web server and you saw in there, maybe I should have stopped it a bit, but in any case, we put in there that we wanted, I think there were 2 VMs in there that you can do multiple VMs at once. So, we say build a VM in there and instantiate multiple of them. The number of instances, I think it's important because I wanted you guys to follow what's happening. So we put 2 of them in there, okay? So we put 2 VMs in there, and then I think in the JBoss component, we are adding also other VMs in the JBoss component, okay? So this will be activity that is given here as an example. Usually they have the policy layer doing this kind of work, okay? So as soon as this is done and mapped in here, automatically the call goes, as we are doing this stuff, goes to OpenStack and we get the event. So the network designer gets the event and we discover all the virtual machines that got created in there. So we discover when they pop up and when they actually boot up, this becomes from blue to green. So we have 2 of them that already booted up. You will see the 3rd one. So that's 3 implementing JBoss function. And you will see the database, I think they put 1 VM here, okay? So this, you'll see it pop it up in that part in there. So right now, I would like to show you guys what actually happens with these virtual machines because as they get instantiated, the policy engine calculates, computes everything that the VM needs. So from that higher level abstraction, which is easy to understand by the enterprise admins, we generate actually specific instructions in there. This particular VM, which is one of the web servers, I'm not sure if you can see it very well, but gets an IP address, public IP address, a private IP address for communication inside the logical topology, and then we generate all the rules inside there. So basically, what are the rules for the web server? And you will see them in there. I'm not sure if you will see them, but trust me, what generates in there generates allowed communication on HTTPS, port 80, or whatever it is, 8080, and HTTP. So allow from the internet communication on that, allow for JBoss, allow for DNS, allow for Puppet, allow for management, okay? So all of those rules are pushed as the VM gets instantiated. VM pops up in the network, I find out about it in the brain. The brain says, here are the instantiation of the rules, IP address, everything. The controller applies it. Talks eventually to other controllers to understand what needs to be done in the overall scheme of things. So basically, that's what this shows you here. So there will be policy components in there. See, we didn't put any QoS, but you could have seen the QoS there. But all the policy rules are instantiated on a per VM basis automatically, okay? And this allows also for policy compliance because you have the higher level view, it's easy to check. It's templated, it's instantiated, you can easily see what you design, and this is automatically done. Okay, I'm losing control of this. So in the meantime, because we did all of this on VSD to make it easy for you guys to follow and for the enterprise admin to follow, but really this is using the OpenStack Nova compute, right? So right now we switch to OpenStack Horizon View, and in here you can see, I should have shown it before we started, but you see here 2 HTTP servers, 3 JBoss, and 1 database VM instantiated. So this is instantiated here, and you know, the only thing is OpenStack doesn't use Neutron, right? It's using our brain. It's talking to our brain to tell it what to do, okay? And our brain talks back, of course, and tells OpenStack what needs to be done. So you will see, if you go in a particular web server in there, you can see the same IP addresses we had in there, and 10.96.47.2. And basically, you will see from a networking perspective, if you go in the network tab, you will see in there the 3 subnets that are related to the application tier. So the website application will have here basically business logic, database, and front end, the web subnet, instantiating there. And of course, OpenStack has like security groups. We didn't get to show them, but pretty much all of this gets instantiated in OpenStack automatically. So if somebody prefers to use OpenStack, they don't have a policy, higher level policy layer, they can just keep using OpenStack interface here. Okay? So this UI example was an example to show you in one shot what VSD can do and what's the value of this policy component, right? What's the value of having a brain? I think that's one of the major differentiators. That's what allowed us to actually provide integration and really be able to provide the solution part of a best-of-breed component. So usually how it works, customers go and select an OpenStack distribution, a Linux distribution. Like let's say they pick up Red Hat or Canonical or SUSE. We identify it, we do adjustments to actually certify with them. It's very simple certification. We test with them and we are able to accommodate easily the integration, the required integration with them that way. So we've been, I think, very successful because of that sort of openness and all of this policy brain that allows us to extend it easily, put modules in there and adapt to different customer environments. That's kind of what I wanted to cover here, so we'll open it up for questions.
So you started with domain concept.
Sorry?
You started with domain, concept of domain. Is domain an abstraction of a zone?
No, the domain is a routing environment. So think in terms of, you have a dedicated set of routers distributed everywhere, right? It's a distributed routing environment. So is that router I was showing in that service topology?
So is it an autonomous system like that?
No, that's a VRF-like, right? If you're familiar with IPVPN, that's a virtual routing and forwarding engine that gets allocated on logical view. Okay? For every one of them. They can have even overlapping IP addresses, right? Okay? So you get one for development, one for QA, one for production.
So then how are you tying that to the DNS?
Well, so the DNS is an endpoint that attaches there, okay? The DNS attachment to the domain doesn't have that much to do with the domain itself. It has to do with defining what kind of policies, what do you allow to talk to that particular service, to the DNS service. So you will allow the DNS port only.
Is it attaching to the fabric?
It's not attaching to the fabric, that's attaching to the virtualized environment. The fabric does just IP, does IP tunneling underneath, doesn't have anything to do with this. This is right next to the server. Everything we instantiate is next to the VM in the server. The VM doesn't have to go back and forth to the fabric. That's bad. That's you waiting for Broadcom to bring features up. It takes a long time. You know, everything is software. It's easy to implement. Yeah. So the fabric does just IP.
So when you get up to the internet, do you have to create bursts on the table?
Usually, So the VRF basically will get created, but it actually leaks into the GRT that connects to the internet, right? So you could have basically internet access through the VRF that you instantiate on the PD or the router.
Does
Yes.
the bring actually push any network information between the, or does it
So you see, to communicate, so we do have basically the capability to push on the PE the route target, which is what you need to make them work, right? So we are pushing really the route target on the PE.
But you still
Right.
have to build the verse on the PE.
Yeah, but usually you see the VRF, because it has to do with the wide area network, it's basically the wide area network team that builds the VRF, right? It builds and puts route targets that have to do with the wide area network. That's in place already when they onboarded that particular instance to cross the WAN, right? When you attach it to the internal part, then you add basically in there a route target. Now the VRF is really requiring there for the case where you have VPNs, okay? You don't really need, if you don't have VPNs running into an enterprise network, you don't really need a VRF in there. We actually found a solution to avoid the need for a VRF, because that was a pain point. People don't have necessarily PE class devices in there. But that's for another presentation, and we are doing some stuff in there to actually plug directly into the internet. For the internet traffic. Think about floating IP and all of that stuff. There are some ways to do that. If you're not from competition, I can talk to you about it.
So, my in each of the tier, right? So, are you doing load balancer in the fabric to multiple VMs in each tier?
Yeah, so I'm sorry I didn't repeat the questions over there for you guys, but basically the question is if you have a web server, you might need a load balancer to build that sort of stuff.
Right.
Yeah, of course, you could build one virtual machine that is a load balancer, or you can have a physical load balancer, and then you will use like a service chaining component to build the load balancer, or you just attach it to the network.
But in your solution, in the demo you showed you have multiple VMs, right? In each JBoss. Your fabric is doing the load balancing there, or how?
For the VMs?
So your three web servers have, they all have public IPs. How would the traffic go to each one of them?
No, so there will be a load balancer in place. Just try to keep it simple
But
to understand.
it's not part of the.
Yeah, it could be a load. No, it could be a load balancer that attaches to the service topology, right? Or it could be a load balancer that is actually in the underlay, because there are a number of shared services that didn't get yet the multi-tenancy, and they are attached to the underlay. The same like the internet access that you were talking about. So sometimes you need to actually go in the underlay and access shared services in the underlay, just because they don't have multi-tenancy, some of the appliance vendors.
Is this a feature that you're targeting to provide load balancing capabilities?
Also, yeah, okay.
Like, when you design the web tier or the application tier, maybe provide some sort of load balancing like OpenStack does?
Also, we do support load balancer as a service from OpenStack. We do have that mapped down, and actually we have one cloud service provider who is actually running with HA proxy from OpenStack. So we are translating that. But for simplicity, I didn't really build this in the last 15 minutes, so I just did it here. But yeah, HA proxy, we have deployments with that, and in general, we have a number of other ecosystem vendors, like I think F5 comes to mind, and some others that are part of the deployment. Any other questions?
You said that you don't need a gateway across data centers.
Uh-huh.
If you want to, most of the time you want to use IPsec or something to, for secure communication across data centers.
Yeah, so I mean, there are a number of cases where we actually were asked to do VXLAN with IPsec tunnels rather than that, right? In most of the cases, they have like most of deployment scenarios we encounter. We saw just basically a private IP connectivity between the DCs, so you can extend the VXLAN tunnel directly. They have a private one between the data centers. But we had some hybrid use case, like there were some AWS came a number of times. There was some cloud bursting requirements, hybrid cloud, where we were asked to go like IPsec to one of our software gateways. I didn't want this talk to be about gateways, but we do support a number of gateways. We support a number of third-party gateways, like Trident 2 based gateways. we have a number of them that we support. We have our own, because when we started we were small, nobody wanted to work with us about 16 months ago, so we kind of already built a bunch of Broadcom boxes. It took us probably like 4 months to assemble the box and build it to a certain level. So we do have our own, but pretty much our focus is to be a software vendor, and we see it as a software gateway and a 1 terabit gateway if people want to go in and out. And we do support both VXLAN and layer 3 termination on our gateway. And I think we are trying to bring everybody up to par, everybody to have the same type of functionality from a gateway perspective. We are pretty open with people to promote it, because, as I said, our focus, we truly believe that our destiny is to build the best policy and controller and be able to push that model where there are many people doing hardware, opening sales channels, being innovative about how they sell, and working with us to actually push this new networking model. Why shouldn't we have, at least in the cloud space, an open networking model where I can do a startup in the hardware space if I have an idea about a new form factor with $5 million instead of begging VCs. No, what is the fabric IP guy? I don't think it's easy to get 50 million, to build a new stuff. maybe he has 50 million, but 5 million it's easy to find.
Did you say you support IPv6?
IPv6 is coming up again and again. I think we have the possibility in the controller. We have so many IPv6 features that probably for us it won't be a big deal to actually instantiate it, right? We have the V6P, all of that stuff already implemented into the controller. That one I didn't cut out because I thought people would come back to V6. But to be honest, there are people asking about it in the forwarding plane. On the OpenStack side, I don't see the things aligning to justify testing in the forwarding plane, all of that. It's something we have though on the roadmap for early next year. So I'm just looking at the business case and looking to see how the customers really deploy this. Definitely controller and the policy part already has the V6 components in there.
Today you communicate only with the hardware is dimension or hardware? You program the hardware as well in the data path, or you just use the
No, so the question is whether we program the Alcatel-Lucent hardware. We've been trying to build it as a generic solution, and actually, originally we started right from the beginning with all 3 main PEs. So we're able to communicate with routers and provider edge devices from Cisco, Juniper, and Alcatel-Lucent 7750. I did have half body from the PLM team at 7750 in my team. So we were able to integrate, we can push policies on 7750 as well. So we can program them with a bunch of policy components, 7750. But in general, we're pretty open to push it down on the other PEs as well, routers. And I think it's a new world. Like if you guys are coming from the networking space, it's a really refreshing experience. Like we have this cloud provider who originally we didn't have the capability to push on 7750 the policy, and I thought it's a big deal, right? And we went there and they said, bring me a PE, I want a PE here because they need some cool stuff with ASBRs and stuff. So we gave them the PE and I said, we're bringing this feature that will control the PE. I said, don't worry about that, I have basically my policy layer in there, I will do some coding and control your freaking PE. And they did actually. I thought, okay, they won't manage to do it. It's basically a new world. They kind of just need a little bit of hand-holding. I think, they need quite a bit of hand-holding. If you look at Neutron, what people did in Neutron, they kind of screwed up the OpenStack networking part. But, otherwise, we have lots of things to learn from them, right? Lots of things. When we started this company, we had a bunch of cloud guys, most of them kids that we picked up from all over the place, telling me this networking stuff is not cool, and I was like, I felt kind of hurt, right? But at the end of the day, we ended up actually learning a lot from them, and we actually realized that it's easy to do networking. This is a new challenge, and it's a very interesting challenge. And you can help if you're coming from the networking background. You can help them by getting involved. I will encourage people to jump on the opportunity and the new world that is opened by this SDN concept.
Yeah, I saw a similar architectural discussion that Matakura did. I think they're trying to fix Neutron. So there are similar kind of functional groupings in architectural layering. How would you compare what Matakura is doing to what you're doing?
Also, we are contributors to OpenStack, right? We had our Icehouse plugin submitted. We increased our team. We have a team that is actually right now working closely with the policy component in OpenStack. We're trying to basically do all of this with everybody in the industry. But it's becoming a little bit like my world ITF experience I ran away from about 1 year ago. It's like too much debate in there, and at the end of the day, you can go in there and add some extensions and agree with a bunch of people that, hey, let's add these policy extensions. And you know, in the meantime, until they figure out what it is, you might be showing them the path by implementing the path a little bit and convince them that that's working, right? If you look at what we are doing underneath that, that VM call we did to OpenStack, we're in there some vendor extensions that are calling basically the VM creation and say map to application tier front end. It's not that much of work to actually do it. But you know, the policy framework that they are trying to implement in there, I think it's also an interesting initiative. Could go a long way, and they are indeed like changing a bit the architecture in Neutron, right? I think there is just a little bit of a period where people will go like two ways with ML2 plugin and the core plugin, and until we stabilize on one plugin, probably we are 12, 14 months away from stabilizing it, okay? So and at the end of the day, the only thing that is important is to actually have the right abstraction layers. If they try to implement in Neutron switching VLANs, you know, and provisioning VLAN after VLAN, provisioning the network node router, it's like manipulating a wooden puppet to go there, you know. You put 1,000 steps in there, it will balloon and it will not work, right? And we have a lot of software that is making our software world fat. So we need to optimize in there and be smart about it, right? We just need to make sure we implement a language in there, and then whoever provides the controller made the best win in there, right? They don't need to focus in creating everything in Neutron, in my opinion.
So you mentioned about the forwarding entity on KVM you pulled into user space, right? How does it work on EXS server?
I'm sorry?
How does it work on the non-KVM server, EXS server?
Well, we did some tricks in there which I cannot share here, but I think for VMware, really, like if you are in the customer base, I mean, for God's sake, they were talking about openness. Hyper-V got ahead of them to implement OVS. If they want to be open, they should freaking just do themselves the OVS implementation in there, right? And I think that's something that they should implement if they want the ESXi to survive, right? I think they just announced an OpenStack distribution. It was just a little bit far from out. It's like, we don't know why they are doing it. They are crazy. We'll do an OpenStack distribution. I think, you know, we need to be like serious about opening up the components and allow for competition. And I think customers will appreciate that. They definitely did fantastic work in introducing these SDN concepts. I was ready to quit high tech and networking if they didn't introduce this. I was fed up. I did LTE and P gateway, so that's awful how many interfaces they have. The innovation, it's impossible. So I'm really grateful for them to start all of this, but looking forward to a good, fair competition.
So one last question from me. You mentioned about service chain, right? Do you service chain third-party vendors virtual services? If you do, then do they need to, the particular vendor need to, you know, integrate with the Nuage solution, some SDK, that kind of stuff, or just plug and play?
No, so part of this application designer, the application designer, I showed the private cloud part, but this could do service chaining actually. And when you pull that arrow down, you can pop up either a simple port or you can pop up a service chain attachment. We didn't create the service chain here. And part of that service chain, the functions have in the background the possibility to insert particular profiles. But I truly hope that we get the OpenStack appliance as a service stuff on the right path. So we keep it open, and that's the programmable framework. It's very valuable, right? They deploy OpenStack, they have load balancer as a service, everybody submits the plugin, customer has the option to go between different vendors, right? I think that's the right way to do it, but on the interim, until that stabilizes, we could possibly do it that way. And you know, in general, we are very customer focused, so depending on how the customer want to go, we truly are trying to push them in the direction of a truly programmable interface.
Have you heard of Juju? Juju and Juju is similar to what you have in the application development framework?
Yeah, we have that part of, I have a bunch of my, so my PLMs are a mixture of all product managers, kind of architects and hands-on guys. They, all of them are using these Juju charms for some freaking stuff in there. I see them working on it all the time. So yeah, so it's part of what we are using to provide different tool set to build deployment components, make it easy to also integrate with a bunch of the distributions that we hit at customer location.
Okay, so what is what is different with if you had to compare with Juju charms, your application development environment? Would you not create Juju charms and do within Juju what you are trying to do with OEM?
No, but that so that basically it's on the application side. Here we're not talking about the application side. We're not talking to the application. There were the application environment that was discussed. Basically, there were a bunch of working groups in ITF who were trying to talk directly to the application. You shouldn't look at it that way, right? There is this policy engine that tells us what they want implemented, right? From a networking perspective, I'm not mixing up basically what's happening inside the application or web server configuration or stuff like that, right? I'm just basically reacting to the VM bring up or container bring up and establishing policies outside on the networking interface, on the VNIC or the handle.
Wouldn't they have to do, when they also do this web server and all those things, wouldn't they have to also open up, you know?
No, you're going down the puppet path, right? If you want to put in Juju charms 1,000 steps, you'll get down a path where basically you'll suffer a lot. I'm trying to say we provide basically, underneath the cover, we provide that translation for networking, right? So the communication down here could be different type of primitives they push down. And we'll take the plugin, there will be basically a small plugin that is developed by the customer to translate that into REST API calls, right? And inside they might be using at that level Juju charms or things like that, but I think that's a small piece of the whole equation in there. It's not the whole brain stuff.
Are you saying that you have in Juju charms some kind of a plugin to do whatever?
No. We do the policy layer. I was talking about the generic policy layer, right? Where we translate basically the policy definition they have in there at higher level, right?
Okay.
So there are different, like there are different basically policy components that are used in the enterprise space. Some developed by themselves. I think we are using in Alcatel-Lucent our own policy layer in there, right?
Okay.
And that's what I'm talking about. We're communicating to that part, not with.
You have some kind of a high availability built up in the controller layer. Like, how do you handle the failovers if my controller goes down someplace, or if I lose the connectivity between the upper layer and the controller? How do I handle this?
No, so there are two aspects here, right? So there is an aspect where the controllers are in active mode, right? And basically one goes down, the other one takes over and picks up the workload. Now, the other part of your question is how do you react if somehow the top layer disappears? In general, what we saw in there is that people want to have like a graceful failover. So in general, they want you to let the VRS layer, the data path, to forward. Of course, you know, it's stale information, and we have a timer in there that could be basically provisioned to increase or decrease the period you keep stale information in there. Okay? And it's the same kind of philosophy applies as you go up the ladder. Of course, in general, new VMs don't get instantiated properly while the connection disappears. But that's you see, this is a very important component, and I think Aldrin Isaac, who's a very smart guy I work with in ITF, he works for Bloomberg. He had a very interesting presentation about the fact that control federation allows for limiting the damage. He calls it blast radius. He said in internet, basically, the blast radius is limited by separating internet domains through BGP. And if you put a controller domain with 3 controllers, right, that's the usual redundancy, right? And you're starting to increase the controller size, right, and the controller processes. If you have one of them going nuts, the others could go nuts too. The blast radius is the size of your data center, right? If you have controller federation and BGP isolates the different components of the brain, then basically one data center area dies and availability zone disappears. The other one is maintained, okay? So I think that's the advantage of federation and isolating the controllers. And you don't have, we have customers who want to do fast failover. They could limit the size of one controller domain, right? They can make the controller domain smaller, and the controller works harder to bring up the networking, right? Has works less and brings up the networking faster, right? If you limit the domain, you have that sort of choice to make it smaller or larger, depending on how much you care about failover times. And I mean, there were some tests we had to do for a customer where we did a test for 65,000 VMs, and they tested with federation versus big brain approach, and I think we did 10 times faster than the big brain approach, because they are, in general, the policy goes down and then the controllers work with each other to bring up networking. It's not the brain that has to populate everything, right? And they had problems with Neutron because of security group to security group, where the brain had to calculate all the combinations, had to push everything down to all the servers, and of course it went nuts and killed everybody, or even worse, allowed traffic to go. If you push the policy down and program the endpoints and let them controllers populate the ACL entries, it works much faster, and of course, you know, you can do more flexible security rules. Okay?
So other than the everything what you showed, like JBoss server and like MySQL database and HTTP, right? You have other also like for NAT or other?
The floating IP program or not. The floating IP that we allocate to the web server automatically programs a public IP and nothing. Okay? So there is a logic that does, again, could be centralized or distributed. I'm leading into what I said I won't say in here, but you can plug into the internet right there, or you can plug it right at the router at the top. But then you need conversion from VRF to GRT. But yeah, that was the NAT function that we added to the web servers.
For the JBoss example, is there anything, is it JBoss specific, or it is just the port, right? We think 8080 is the port I want and this is my, or is there anything more than that for it to be JBoss specific container?
No, well, so you see, I don't know if you noticed, but we mapped in there application into application. Okay. You can bring and design an environment that has its own shared services, right? You can. We already did on a per development domain their own DNS. You can put their own IPAM, and you can put their own Puppet, right? You can put it inside the project if you want it. So there is a recursive component in there. But those were the basic components where you give them the possibility to avoid that list and, excuse me, have everything programmed in there. The list, the table list of services, it's basically in there. Okay.
So, another basic question: how do you take into account middle boxes? He was asking firewall, IPSs, IDSs. Are they outside the control of the controllers? Who controls them? How does it work?
Yeah, so the question is, how do we take into account the appliances? So it's similar with a question I heard from the audience around here. So basically there are, as I said, we have a service chaining design, which could include what we call like appliance function, right? And in there, underneath that module that identifies the appliance, you can put a profile in there that you can push in the appliance. But we prefer basically people to use the OpenStack environment, or have their own basically kind of LBus service or firewall as a service component that allows for people to actually just submit their plugin and be selected, right? That gives them choice, in my opinion, and aligns with our view that we should basically push in the industry a best-of-breed solution. We want to allow them to cook with organic meat, not with frozen food, right? So
I came to learn about your company. Where is the strength of your company? Is it in the controller or in the virtual switch that you have, or the chaining, if, API that's sitting at the top?
Also,
Where is the center of gravity for your company?
the center of gravity for our company, whether it's, where is it? So we have three components, right? We have the policy and we have the controller, which are the main focus for us. And the southbound interface and the northbound interface are designed to be easily expandable and easily used, right? And the UI, it's an example of how people can use the primitives we have inside the policy brain, right? But you see, based on whatever forwarding plane we have in there, if there is a startup that comes up with a hardware running Linux-like operating system, I'm able to actually submit our VRS agent in there and program it, right? We have some initiatives in the area of, branch interconnect as well, where we are using that sort of philosophy. Okay? So there is an expandability into the hardware, and from an appliance function, I think we were working to do the distributed internal firewall and chain the internet-facing firewall, because that's what we are seeing in the industry, right? Despite the whole discussion about distributed firewalling everywhere, people still have actually a mixture between a distributed firewall in the internal component, which is actually about 80% of the rules, and the centralized firewall is kind of left in place that's harder to touch. The firewalling rules we put in place could be potentially going into replacing that centralized firewall, but I see that as probably 12 to 14 months away from happening. Okay?
Taking the OVS scale length from the kernel module and running it as a process into the user space is very correct. Is that?
No. No. So the question is whether we said we are taking the OVS kernel module and running it in user space. No. The OVS, the Open vSwitch, has two modules. It has a kernel module and then has an application module. And it's pretty much similar with what you have on a networking card, where you have a, kind of control plane view, mini processor there, and then you have the MPU, the forwarding element. The kernel is like an ASIC, if you want, the kernel module, okay, in OVS. So basically, right now OVS evolved to do VXLAN, is able to be programmed for L3 as well. So the only thing we are replacing the OVS user space module, because we need to add in there more intelligence. That gets hit just when the first packet comes in. That's the usual networking that happens in a line card, right? First packet comes in, hits the control plane module, and you do walk through all the policy tables, all the layer 2, layer 3 FIPS, and program a specific flow into the ASIC. We basically just maintain the OVS kernel module, because that's what all the distributions support. They allow you easily to replace the user space. Initially, they weren't doing right VXLAN, they weren't doing right GRE, so we were kind of forced to model with the kernel space, but we took it out in April just because the benefits of being certified. Some people are just replacing altogether OVS, and I think they will have a very hard time getting deployments actually in the enterprise space. It's not, I mean, for the sake of technology, we wanted to go there. We said, oh, we just, these guys wrote OVS, they didn't do it right, we'll do it right, it's not a big deal. Then we realized that deployment-wise, people like open source, they want to use distributions, they don't want you to change the OVS, and it's not such a complex piece of software. And we want to contribute and enhance it, and there are other SDN companies who are also working hard to enhance it. We got megaflows in there, we get DPDK in OVS. It's a bit late, but it's not a big deal compared with the distribution problem.